So guys, in this video, we're going to go over the law of signs and what's called the ambiguous case. So we talked about before that we can use law of signs when there was when you're given two angles and a side. But what if we were given only one angle and two sides? So it's an ASS problem, okay? So this is the way I remember it. I call it the ambiguous case. Okay. So this is what it looks like, right? If we're given a triangle ABC, uh, little a is 19, C is 10, and then the measure of angle A is 111. So you see how here we're only given one angle and then two sides. So that's why it's an ASS problem, okay, or SSA. But when you're given one angle and two sides, right? And the angle is non-included, it's an ambiguous case, okay? But we can still set up a law of signs problem, right? If you're looking at it, you're like, well, it doesn't look that much different. Sine of 111 over 19 equals sine of C over 10. Okay. So what'll happen here is we can essentially just multiply both sides through times 10 times 10 times 10 here. This will cancel out. So you're just left with sine of C is equal to 10 times sine of 111 over 19. All right. And then to solve for C, we would have to take the sine inverse of both sides. So you would have to take this here and then do sine inverse. And this is how you'll type it into the calculator. Sine inverse of, you would do like control divide on the Inspire, 10 times sine 111 over 19. And then just make sure you're in degree mode. And angle C should be about 29.430. So I'll round it to 3 decimal places like the AP exam, okay? So we're going to explore like what happens here if when we do the ambiguous case as well. So for now, this is just a regular law of signs problem, okay? And we're gonna go back. We're gonna come back to this in a minute. Okay, so let's take a look and try example one on the next slide here. So triangle ABC, measure of angle A is 33, little a is 12, little b is 15. So I'll sketch it. So here's the diagram here, and it looks pretty similar to what we have here, right? We have two sides and a non-included angle. Two sides, non-included angle. So the setup will look similar. Sine of A over 12 is equal to sine of B over 15. We'll have 15 times sine A over 12 is equal to sine of B. And then B is going to be equal to sine inverse of that fraction, 15 times, sine of A is 33 over 12. So let me just fix that. Okay, so then when you type this into the calculator here, rounding to the nearest degree, B is about 43 degrees. Now, the reason why this is the ambiguous case is because what we need to check as well, if you recall from the previous unit when we were solving trig equations, right? This number inside the inverse function, sine inverse, is going to be a positive value. All right. So recall Sine is positive in quadrant 1 and quadrant 2. So what could we do to figure out a second solution for quadrant 2, right? So if we were to figure out quadrant two's value for angle B, we would subtract 43 from 180 to give us that our second solution could technically be 137 degrees. Okay. So what does this mean? We can actually have two triangles for this figure. So let me do this. All right, so we have two possible triangles here, okay? So the first triangle here, angle A is still going to be 33 degrees. Angle B, when we first found it, was 43 degrees. And then angle C, if we were to add these two together and subtract from 180, would be 104. All right, so this is angle A, angle B, angle C here. So angle A would still be 33 degrees. Angle B would be 137 as a second solution. And then if we were to add these two together and subtract from 180, angle C could also be 10 degrees. Okay. So what we have here is that because this is the ambiguous case, we can have two possible triangles. And that's kind of the added wrinkle here with this set of law of sines problems. We need to check if it's an ASS, right? If you have an angle and two non-included, sorry, two sides and a non-included angle, we have to check for the ambiguous case. Okay. So now looking back at the do now, the ambiguous case applies, right? Because we have a similar diagram. Why is there only one triangle possible? Well, let's take a look at what would happen if we were to try to find our secondary angle, right? So the measure of angle C in quadrant 2 would be 180 minus 29.43, which is about 150.57 degrees. Okay, so now let's think about what would happen if this angle C was 150 degrees, 150.57, given that angle A was already 111. What would happen? Well, hopefully you remember that a triangle is only 180, right? So it wouldn't be possible. So if we were to use the second solution in quadrant 2, the angle measures would be greater than 180, so you could not form a triangle. So that's why, even though we didn't really know the ambiguous case existed yet, we kind of stumbled upon it, and there was only one possible answer anyway. Okay, so for the do now, there was only one possible triangle. So I just modified this here so you cannot form a second triangle. All right, so that is kind of the big ideas for the ambiguous case.